All right, so we're going to take a look at the distributive property in the other direction today. Now they're going to be written in factored form. We're going to expand them, so we're going to go backwards on what we did yesterday. So let's just start with how would we show this with the tape diagram? Well, pretty simple. I'm just going to do this. I'm going to show 3, and I'm going to show 5, a little longer, added onto it. That's a rectangle. We'll try to close it. So then if I told you 2 groups of that, right? This means 2 groups. I don't know why I put quotes there. Two groups of 3 plus 5. Well, how am I going to show that? I'm going to show it like this. I'm going to show 3 and 5. I'm going to show 3 and 5. So I can see that. I can see right here, this is 3 plus 5. And this is also 3 plus 5. So how can I think of this? Well, I can think of it like this. I can move things around. I know that with addition. So I can slide my 3's close to each other, like so. Slide my 3's close together. Because I know I have 2 3's. And I have 2 5's. So I know I have 2 3's and 2 5's. All I did was I rearranged. I moved this 3 over here and the 5 over there. It's addition. We can do that. So knowing that, look at what we can say. We can say 2 times 3 is 6, and 2 times 5 is 10. So it looks like I can tell you this. It looks like I can tell you 2 times 3 plus 5. Basically what I just told you was that's the same thing as taking 2 times 3 and adding it to 2 times 5. So we just multiply that outside number by each of the inside terms. So I know it's 6 and 10. So I can arrive at the answer of 16 pretty easily. So I can write this as 6 and 10. Let's try another one. This time with some variables. So here now I've got A and B. I'm not going to show this much differently. Here's A, and I'm going to make B a little smaller. There's A and B. But now it says, okay, now I want 2 groups of A plus B. So if I want 2 groups, think about how we're going to draw that. All I'm going to do is I'm going to think, well, here's 2 groups. There's A and B. And here's another group. There's another group of A and B. So let's rearrange things. Let's see if we can make this a little easier to write instead of 2A plus B. Well, I'm going to move my A's close together. My A's, here's A and A. Just slid them over, rearranged them, and then I'm going to move my B's together. And so now what do I have? Now instead of 2 groups of A and B, I have 2 A's, and I have 2 B's. So I have 2A plus 2B. So it looks like I just told you, you can take this, and by I told you, I mean we figured it out. This means 2 times A plus 2 times B. Or, more simply, we can just write it as 2A plus 2B. We don't know what those variables are. Oh, geez, there you go. So yeah, we just took 2 times A and 2 times B. We multiplied the outside number by both of our inside terms. All right, let's go ahead and keep going on and see if we can maybe model this with some area models like we did yesterday. So let's think of it like this. This one is taking an area model, right? And it's saying, here is your model. It says you have 2 times 3 plus 5. I didn't really draw my model very well. This is 3. Obviously, 3 is not bigger than 5. But this is what we're saying. 2 times 3 and 5. Well, what is 2 times 3? 2 times 3 is 6. What is 2 times 5? 2 times 5 is 10. So I actually have 6, and I actually have 10. So I can say this right here. This is equal to 2 times 3 plus 2 times 5, or I can say it's equal to 6 plus 10. Obviously, we can say that's 16. Let's try to show the same thing with variables. So let's try this over here. So again, I'm going to draw my area model. And I know I have A and I have B. But I also have 2 times A plus B. So I have 2 A's, 2 B's. So what's 2 times A? Well, it's 2A. What's 2 times b? We're finding the area, so we multiply length times width. I get 2b. So here I can say 2 times a plus b. That is the same exact thing as doing 2 times a, so the outside number times one of the inside terms, add it to 2 times the other inside terms. So simplifying this down, it's actually 2a plus 2b. So we're saying this thing right here is equal to this. Well, let's prove that. We just said, here's what we said. We said this right here, we're saying these two things are the same. We're saying they're equal. Well, let's prove that. Let's let a equal 2, and let's let b equal 3. Let's see if this actually works. So let's try it. So 2 times a is 2, b is 3, or let's do it like this. A again is 2, and b we said was 3. Let's try this. Let's see if they're actually equal. So over here, I'm going to try this side first. Over here I know parentheses first. 2 plus 3 is 5. 2 times 5 is 10. Let's try the other side. 2 times 2 is 4. 2 times 3 is 6. And 4 plus 6 is 10. Does 10 equal, does 10 equal 10? Yes, it does. So we proved it was true. All we had to do is say, hey, here's what A and B are, and we proved 10 equals 10. So yeah, these two are the same thing. We could change it anytime, and we'd be good. All right, let's try this without a model then. So here we go. I've got 2 times the quantity 3x plus 4y. Let's start with a model, and then we'll see if you can try some without. All right? So let's see here. So I have 2 times 3x plus 4y. So I've got my area model, and I've got 2 terms on the inside. So I drew 2 boxes. I know I have 3x plus 4y. And I have 2 times that quantity. So first I'm thinking 2 times 3x, and then I'm thinking 2 times 4y. Well, what is 2 times 3x? Well, this is just like expanding and simplifying the expressions from earlier this week. So this is worth 6x, and then this one is worth 2 times 4, this is 8y. So we can say this is 6x plus 8y. But now I want you to try to do all this without a model. This is something a lot of people normally haven't done in years past until 8th or 9th grade. So we're well in shape here. We're doing fine. So again, I'm going to say the outside term times the inside ones. When I move away from my model, I like to remind myself of that by drawing little arrows, so I know to multiply by both terms. I don't really have a name for that, but I guess you could come up with something fancy. But it means 2 times 3x plus 2 times 4y. So here I could say 6x, 2 times 3 is 6, plus 2 times 4 is 8y. So there we go. That's what we got. We can get this simplified down into expanded form using that. Okay, here's what I'd like you to do. I'd like you to try this one, number 1, and I'd like you to try number 2. I'd like you to try these two on your own and come back and check, and then we'll go to the other two after that. So again, try these two, come back in about a minute and a half, and see if you agree with my answers, or see if your answers agree with mine, rather. I think there's not really much room for discussion since a video can't talk back to you. So pause, try these two, and come back. All right, so I again like to draw my arrows. So I know it's y times 4x plus y times 5. So what is y times 4x? I can rearrange these. I want to put them in alphabetical order. So I'm going to say it's 4xy plus, what's y times 5? The adjacent form of multiplication, it is 5y. So there we go. Let's keep going. Get these written in expanded form. So again, I like to have my arrows. 8 times h. 8 also times 3. So it means 8 times h plus 8 times 3. And what is this equal to? Well, 8 times h is 8h. And 8 times 3 is 24. So there we go. We've got those. So hopefully you've corrected some of the mistakes you were making. Now go try number 3 over here and number 4. Again, take about a minute and a half to try to figure it out, and then come on back and see if you got your answers right. So again, I like to get started by drawing those arrows. You don't have to do that. This is just something I do so I don't forget to multiply both terms. Otherwise, sometimes people just write the second one down by accident. So here I'm thinking 3 times 7d plus 3 times 4e. So that would give me 21d plus 3 times 4 is 12e. So there's my expanded form. Last one, we have, this is 3 times 2h, and then we still have to add it to 3 times 7. Gosh, I'm big on the 21s today. I'm sorry about that. 3 times 2 is 6h, plus 3 times 7 is 21. So 6h plus 21.